I hope everyone is enjoying NIWeek. Welcome to 2015 NIWeek, the beginning of the sessions. I'm glad you picked Configurator framework to be one of your first sessions this year. I'm Benjamin Celis. I'm one of the senior system engineers from the embedded group. Daniel Smith is also one of our system engineers for the embedded group. And what we're going to cover today is the Configuration Editor framework. Can everyone hear me all the way to the back? Perfect. So, the Configuration Editor framework is one of the libraries that we have developed in System Engineer. Part of the things we want to do is reuse code so we can develop our proof of concepts and in general be more efficient in our work. The thing is, these tools that are pretty useful for us, we think they are also useful for all of you, and normally we publish them. So we have them in ni.com/reference design. You can find all our libraries and all our reference designs. And this one we have been using extensively for the last 2 years. The configuration part is extremely useful. So in here, who has ever designed a system that needed some configuration? Okay, I think everyone has to deal with configuration files at some point. What is the most common way everyone has done that? How do you configure your systems? A file. What type of file? XML. XML is pretty common. Before that, it was common using a CSV file. Some people like to use Excel for configuring the systems. So there's a lot of things. The thing in general is we do need a way to configure our system, but the problem is what happens if we don't configure our systems. We have systems that don't need configuration at the beginning. And many times when we're designing our system, we might say, oh, I don't need to configure anything. Systems that we might think like this is a clock, a scale, a specific data logger. And many times we start with that mind frame. We don't have to configure everything. Everything is going to be hard-coded. Let's go with this. What happens when we start with this? One, we don't specify any time to designing tools for making people to configure our system. And we don't even design what our configuration will be. So when do we decide how we configure the system? Once the complete system is built, and then we realize, oh, this feature needs to be configured, or now the customer is changing something, and I need to specify what they're doing. The thing is, in general, most of our systems are dynamic. Everyone in the room lifted their hands, we need to configure something. Even when you're using LabVIEW, you configure it through an INI file, and you can go and change stuff directly there. Things that we might want to change. So in general, if you have multiple of the same system, you might want to change something. So if we have 20 compact videos monitoring a bridge, you want to know which one is sending good information. You want to know if it's on the top of the bridge or on the bottom of the bridge to figure out what's the measurement. You don't really want to change the code because both are data loggers. Both are having the same information, just the configuration is different. And we need to be able to specify that. Or what if we're doing a tester? Maybe we have the same test, but we want to change a limit. Or instead of 5 volts, it's going to be 6 volts. We don't want to go change all our code, deploy the system, rematch the system, just to change a 5 volt limit. So we want it to stay in configuration. Or at the same time, we have a system with different conditions. If we're deploying a smart machine that is controlling an oil rig in this desert, it's not the same thing that if you're deploying it in Siberia. The temperature is different, you need to scale the values, you need to change things. But you don't want to change your code. So some of the things to configuring is, or the most common things is, for example, IP address, acquisition rates. You might want to change the configuration settings. Sometimes it's just the application parameters. Sometimes you don't want anything big to change. And depending on how many parameters is, what tools are you going to be using. One of the really interesting things to configure is when you're building plugin-based systems. So for example, in here, who has used Internet Explorer or Chrome? Yeah, everyone has used them. So when you want to open a PDF file in them, do you have to go and download a different program or do you have to modify it? No, you just download a plugin. But when you download those plugins, you need to be able to configure them. And you need a flexible way to configure them. The problem is, when we get into configuration, there's basically 3 types of way of configuring a system. The most basic one that I would say we try to, well, we don't want to do, but we end doing around 70 or 80% of the cases, is the user directly modifies a file, and we feed that file into our program. So if we have an XML file, oh yeah, we can change the parameters there, and then my program reads it. What's the problem with this? Sometimes you have 3,000 lines of XML file, and when you want to modify a parameter, it gets hard. Especially if you have multiple of the same types of machine. For example, if I have a generator A and a generator B, I might have temperature in both of them. So if I want to modify the parameter for temperature in one, I have to figure out what specific part of my XML file has it. And also one of the main problems is, if users are modifying the file directly, they can input invalid information. They can put things that are not there, and that makes that your actual program has to be aware that configuration might be invalid, and has to prevent that from failing the system. So that adds a lot of extra error handling and adapting your system. So sometimes we go a little bit higher. So a lot of people like Excel, because Excel is really easy to edit. So you can go create an Excel file in which the user can input all the information. Then after that, you run a BI or some program that changes that Excel file into an easy to read for the machine's file. The problem with this is Excel is not really a configuration editor. You can add macros. You can add a lot of extra features to protect your system. But still, and I have suffered from this in some projects, is you have your nice table protecting some cells. You cannot type something in here, but they go and copy the cells from another sheet, paste them there, and then all the security goes down. So ideally, what you need to have is a user interface in which the user can configure your application. This creates the file for your machine, and that is what is read from your system. Why is this important? Because it's not the same thing when you're configuring your system, what you need to see, for what your actual runtime code will need. Probably you need more information that is in an array of several elements. But if you give a user a 300 channel array with all the parameters, it becomes really hard to use. So that is the main reason why we need a configuration editor. You need one because editing files manually takes time. It's prone to errors. I have spent in the field hours trying to debug systems in which the problem was somebody mistake a dot for a comma in the file, and that is just messing all the file. How do I prevent that? I create a program that doesn't allow you to put the comma or the dot. It's just the right values. And you can even put, oh, this value is outside of the limits. So that protects your code and makes the user experience a lot easier. At the end, that's one of the things that has changed a lot in the last years. I don't know how many of you create user interface for your customers. I think a good amount of you. If you remember a couple of years back, you could give them any user interface and they would be happy. But now they are like, oh, my iPhone has a really nice screen. I can do this, I can drag things. Can I do the same in your user interface? And it's a lot of things of the perspective or the expectations of user interface can change. So for some users, if you still give them the huge XML file, they will not be happy. And it will be a lot slower to use. So in general, it improves the user experience. It also allows you to share information. Why? Because if I'm configuring a system that might have, for example, tags that I need to use in different parts, when I configure it in one part, I can make it available to other screens. And it makes a lot easier. And also, if you have a tool like this, you can create plugins and plugins for configuring those plugins, which allows a very dynamic experience. So in general, let's say we decide we want to use a configuration editor. The main problems I have seen is people leave it to the last. They don't add any time to build them. So it's like, oh yes, configure the system, you have 3 hours to build this thing. And in general, building UIs takes a lot more time than just building code. So the things that you need for your configuration editor is one, it needs to be scalable. Why? Because you're configuring things and normally they change. In general, I don't think I have found any single project in which requirements don't change. So if we are expecting requirements to change, that means configuration is going to change, and we need to be able to scale in our project. Also, a really thing I consider is extremely important is the file you're exporting or the file you're going to use in your system doesn't have to be the same way the user is seeing the information. Why? Because if for my program, what I need is just a big array that contains all my objects, and I'm just going to use a for it, yes, for the machine and for my LabVIEW code, it makes a lot of sense. For a user configuring it, it might be easier to have a table, or it might be easier to have a preview of how they're configuring your system. Now, also one of the errors is if we display all the configuration for all the users, they're going to try to move it, even if they don't really need to modify it. So it's good to display just the information the user needs, either by having user levels or by just splitting into tabs, having an advanced tab and a basic tab. There's a lot of ways to see, and it's just displaying the right information on the right time. And one of the most important things, it should prevent you from creating invalid configurations. If your system can detect, oh, this is invalid configuration, and prevent you from setting it on configure it when you're configuring it, it will save a lot of time. Why? Because if I cannot have negative values, and I start typing negative values, if I see it when I'm configuring it, I will realize, oh, this is an invalid value, I have to change it. But what happens if I go modify my Excel file, put an invalid value, and then send it to my system? When I see it working, it's like, oh, it's not working as if it has a negative gain. Why? Because it's ignoring negative gains. And it ends being a lot of debug time. So in order to service all these requirements and to make our life a lot easier, what we have in the system engineering group is the configuration editor framework. This configuration editor framework is a tool we're using for our own configuration systems. Actually, two of our new frameworks, that is the SPI framework and the Tagos data framework, the configuration is based on the CEF. It's a really good starting point. You go into projects and you can create it. It includes classes that you will just override the specific needs that you want. I will get into a demo for that. We also include two APIs, one for tree control and one for subpanels. Who in here have used the tree control in LabVIEW? Who in here has trouble making advanced features while using the tree control in LabVIEW? So that's part of the things that we have added. It also includes it's really easy to modify, it's really easy to add behaviors. And in general, one of the things I like is you can add multiple views to the same data. So what we're going to get in general when you create a new project is you're going to get a navigation window and you're going to get a configuration window. I think this is pretty standard. I think everyone in this room had at least see a screen like this. Why is this useful? Because you can click on the specific part that you want, and you will just display the configuration for that node, for that object. Now, how we're doing this is we provide the API for the tree. We have some really nice features, so you can add items, you can duplicate them, you can even drag and drop. Have anyone tried to make drag and drop in LabVIEW tree controls? It's really interesting. You have to do a lot of things. In here, we already have the API, so if you want to drag and drop, you just have to enable it. It's an option, and you can drag and drop items to it. You can remove, and also we have a lot of options for right-click menus. Also, we have the plugin tree control, and each node has a different edit time behavior, so it's pretty nice. And the other thing that I like a lot is the configuration file and the view don't have to be the same. So with Advanced Configurator that I will show later, I created this same configuration. This is the file that I have. This is how I can do it through the configuration editor. So who would want to prefer modifying the name of a channel in this file rather than using that structure? Now, if we go with a customer, what do you think the customer would be expecting if you tell them, yes, the system is also almost running, just if you want to change the names, go and modify this XML file. I think a lot of them won't like it.
It's human readable.
It's human readable. I completely, and human editable, and you don't need high technology. You can use Notepad and you can open it. But that's what the customers are expecting now. So how we achieve this part, and this is the basic part of the CEF, is we have a central repository that is how we manage the data. This place you can store information how it's easy for you to modify. So if you want an array because it's easy to parse, it's easy to search the objects, create your array here. And then after this, you will have the different views. One is the tree view, that is the tree that we had with the front panels. You can create files. So for example, with the load method or save method, basically you're converting from this repository into a file. From the write tree and read tree, you're writing from this repository into a file. But what happens if I just want to show it as a table? Well, you can create custom methods and pass it as a custom view. Now, these methods is basically the main reason or what makes it really easy to work with the CEF. So what you do is you get a method that is called getText. In this one, basically, you configure what information is going to be displayed on the tree. We have the UI red. Basically, you just pick what UI you want to be displayed on the right side. To repo and from repo basically is the methods that are going to be called from sending and receiving the information from a tree node into the repository. Shortcut menu customizes when you right-click, what information is going to be displayed. And duplicate is, sometimes you don't want the same behavior when you click and duplicate a group or duplicate a channel. You can override how that happens. So let's go into a demo to start seeing how the code works. So in general, when you want to create a new system, you can come here, create project. You will have in templates. We have the compression. There it is. So we have both. The advanced configuration editor framework, I will talk about that one later, and you have the configuration editor framework. This is the basic. It has just the bare minimum, and it's easier to adapt. One of the reasons we have these two is because sometimes people think it's really complex to start removing things and see what will work and what won't. So the configuration editor framework is the bare minimum that you will need to get the configuration started. Once you click here, next, you can configure your system. And at the end, what you're going to get is a project file like this. This one already has a couple of classes implemented, so you can see how it's working. And let's see. I have already a system right now loaded. So one of the nice things in here is, in general, you can right-click, add, and I can add new groups. I can also, in the group, I can right-click, add, and if you see, I can see current channel and voltage channel. If I duplicate a channel here, I can just click duplicate, and it copied with the same name. But if I do it on a group level, and I click duplicate, it added a group copy to the name. So if you notice, there's a lot of really simple behaviors. So how do I configure them? How do I modify them? And that all goes with the configuration editor. One of the nice things in here is, if you're not familiar with object-oriented, you don't really have to be familiar in the sense you're not designing the system. You're just implementing a framework. The level of knowledge that you need for object-oriented is how to override a class and how to write a simple VI. So what you have to do with that is, in general, you will have your classes. You will create a new VI. So for example, I have here UI red. This one specifies what VI is going to be called. And if we look at this VI, it's extremely simple. I just have a static reference to the VI, and when I click, the framework handles how to put that into my script file. I don't have to do anything else. If I want to change the edit menu, so I can open the edit options, and this is the VI I get. So the things I have is, on the top part, I can just wire an array. The top array specifies the name that it's going to have on the menu. So if I just want it to be called voltage, I will just put that. And on the other, I actually have the class name that is going to search on my disk. Then I have the options if you can remove it, if you can move it, or if it can be duplicated. Just by setting these options to true or false, you can configure the behavior your system is going to do. Also, one of the things is, in general, for example, I can drag a channel directly into another group, but I cannot drag the channel into the compact tree. So a lot of those behaviors are already defined by the framework, but can be overridden. Because what it's doing is detects what classes are allowed under that node and allows you to move it there. So, for example, the top level VI that is here, serial, I cannot remove it, I cannot move it, because I just check that options out. So it's really easy to start modifying and adding stuff. Another thing that is nice is, yeah, probably it's really nice if I just want to check one channel, see all the configuration. But let's say I didn't finish configuring this system, and I have the sensor ID wrong, or the I/O module wrong. If I have to go through right-clicking on any of these ones to change all of them, it will take me a lot of time. One of the nice things in here is Wait. Sorry, what's showing the... In here I have tools. I can show multiple parameter editor. And it will show me a table that contains all my channels. So right now, if I have, for example, the channel name is duplicated, it's easier for me to go here and start changing them to the right values because it's a table. Once I finish, I click OK, and that will update everything. So what I'm actually doing is the table doesn't write directly to the tree. The table writes to the repository, and the repository writes to the tree. The nice thing with this is if you change or update one of your views, that doesn't break all the views that you have. It's just the view and an interface to the repo, the things that you're changing. So that makes it really easy to scale and really easy to modify. Now, in general, we have been using it for a lot of projects. I know even an Alliance member that what they did is they built in here their test sequencer, and their test sequencer actually is configured through this. They basically run in this interface. So there's a lot of things that you can do. But in general, working with some people, these are the main issues they have seen working with the CLA. The first one is it doesn't enforce versioning. And in general, one of the key things for any configuration file is have versions. If you don't have versions, you risk losing information. You risk having to configure everything manually again because you cannot import your old file, which allows having errors, which might stop a production plan somewhere. So you don't really want to do that. So including versioning is extremely important. And in the advanced template, we're enforcing versioning. The other thing is, in general, when you're building a configuration editor, you need to build how the to repo and from repo are working. Because with that, you're specifying how the information that you have on your node is converted into the repository. And if you have several nodes, one under each other, you have to figure out how the lowest end node passes information to the top node if they contain the same information. So a lot of people had some problems with that, or were not sure what was the best way to implement it. And the other was, how do I design my repository? What do I put there? So in order to simplify all this, what we created is the advanced template. So the new advanced configuration, we released this one like 6 months ago or something. We learned a lot of the things from the Tacos data framework. We're having sessions and hands-on on that. So if you're interested in that library, is one of the latest we have in System Engineer for single point machines. So smart control machines or slow monitoring machines are pretty good with that system. And what we got is this. So if you see from the same picture I showed before, what changes is the repo is already implemented by us, and it's a hierarchical repo. The tree stays the same, but we created a child class of node that is called serializable node. And that one also has a configuration class. So it's contained inside of that. So that's already built for you. And we also created a PDF file that is a file that is pretty generic. We have systems that just read it. And one of the nice things, it has versioning in it. So we're sure that if you upgrade, there will be ways to upgrade it. So the first thing is the configuration class. This is a very simple class. In here, what we're storing is the configuration for your node. One of the reasons we built it as a separate class is in several projects, especially in embedded, what we had was an object for configuration and an object for runtime. The problem is, maybe in the configuration one, I want to access Excel, or I want some Windows-specific functions. And on the runtime, I want some real-time specific functions. If you have one of those pulled into the library of the other, you will get a lot of errors or linking issues when you're deploying your system. So the easiest way to do that is have three classes. One that is what you display, and is the node. One that is the configuration that can be called either from the node or from your runtime code, and actually the runtime code. So the things that this configuration class has is really simple. It has a unique identifier, so there will not be two of this class. So you can detect if an object is duplicated or it's a new object. Then we have a couple of key-value pairs in which you can start and modify anything that you want. For example, alias, execution class name. And it also has a couple of methods, really simple ones. Initialize, basically you initialize what information it has when the new object is created. It has a toString, a from string, so we can actually convert this into an XML-like file. And one that is really nice is validate. This is an override. So if there's some configuration that is required to be valid for your system, so for example, if you're configuring a data logger, something that might be important is specifying the path. So if you don't specify the path, you want to know it's invalid. So you can put that in here. So when you're just converting from and to, you can call this validated part. The other part that I say is extremely important is versioning. We were building a tester, and something that we had is, we built first, it was not the best code you can see, and it was done in a hurry, but I think that's how most of us work. We have to build something in the last minute, and sometimes we try to excuse that with not the best practices. The problem we had is we had a cluster, and each cluster, in this cluster we had a cluster for each test. The problem was that every time you have to modify something, you would have to go and change this mega cluster. And at some point, someone in one test added one parameter. So the problem is, the file I generated to the new parameter doesn't match. So I cannot just import it into the cluster because I would have errors. So normally you would have to build a tool. But in order for that tool to know what it has to convert, it needs to know the version. So a really simple way to do that is you get your version. So in here I'm storing what version I have. I'm storing the data, I'm getting the channels. And when I'm reading the information back, I will just get first what version, then I will have a case structure in which I will decide this is a cluster with 3 elements or a cluster with 4 elements, and then I will modify the elements I have. In general, versioning is really important. I would say I lost a lot of hours in a really important project because of versioning issues. And that's why in the advanced configuration is something that we're enforcing. The other thing that is really important is the serializable node. This node is just inherits from the tree control node, so you have all the same methods, all the same behavior. The main difference is, instead of storing the configuration information directly on this node, you always store in a configuration class, which is inside of your node. I mean, it's really simple. The main difference is now you have to create an extra class, but I mean, it makes it more modular. It makes it easier to distribute your code, and you get basically the same code information. The difference is now you're going to have a configuration class and a group node. The other one that is nice, and actually Daniel spent a lot of time, is we already create a repo for you, so you are going to try to get information in and out of it. So the hierarchical repository, how it works is, it specifies what node is going to be the root, what's on top. Then it has an array of hierarchy of what node contains, which is the name of the node which are the children. And at the end, we just have an array with all the configuration. So with this, we can have the configuration classes, and then build all our tree up and down. One of the nice things is we also have now all the APIs. So when you install this in the file, you will get to get alias, to search an alias. So if you want, for example, a node called temperature tree, you can search by temperature tree directly on the tree, and it will retrieve the configuration for you. So if you need to just get started and get something working really fast, this is the best option. And this is the file format that we're having right now. So if you notice, here's my repository that contains all my information. Then what we do is, using the toString and fromString methods, we basically convert everything into strings. So if you notice, this is the same, just everything is string-based. And then we convert that into a XML-like file. Right now, it's not exactly XML, because when we built this was designed for embedded systems, and we wanted it to be as fast and efficient as possible. So Daniel spent a couple of hours tweaking it and make sure we load it a lot faster. Now, let's go into the compression editor. So that's the base compression class, and this is the advanced one. So I just want to compare the classes with both of them. So if you notice in here, I just have channel, group, current. On the advanced one, the difference is I have channel node, but I also have a configuration channel. Exactly. So that's the main difference between one another. You will have an extra class, but programming and creating your application will be a lot faster. Now, one of the nice things with what you can do with the CEF is you can create a lot more advanced configurations. So this configuration editor is what we have created for the tag-based data framework. There's a couple of other sessions that will cover that, so I'm not covering it here. But I wanted to show you how the CEF looks in a more advanced way. So, for example, in here, one of the things I have is I can create different modules. So we have already all those modules. All of them are plugin based. So what we do is you just install the system. If you specify the path in here, it will search for them and we'll add them to our system. So it's really easy to add extra configuration. Then, for example, here on the TMS file, if you notice I have a cross. And that's because I just overlaying on the glyph because I have not configured the path. And in the path, it's marking me with an X because I don't have valid paths. Another thing is, for example, I can come here and create tags. So when I create a tag, I get my dialog. Let's call this tag 2. So once a tag is available or creating in my system, I can go to another module, for example, this TDMS data logger, and I can see, oh, there's a tag 2. I want to log it too? Sure. And I just add it to my file to log. So it's nice because I'm sharing information between all my different views. One of the things is Scan Engine is writing to files, so I can restrict, there will be no more than one writer to each tag. So you can make sure your configuration is going to be valid. And it's really easy to scale because I can add extra modules, I can add extra things, and all this is built on top of the configuration editor framework. Now, in general, where can you get it? Is you can get it directly in NI.com. You can search for CEF, or even better, you can go to NI.com/reference designs. In NI.com/reference designs, you can find all our reference designs from the system engineer group. So you can find here CVT, CEF, the new SPI framework. All the frameworks that we're developing will be in this place. And also, one of the new things we're trying as a system engineering group is sharing the source code and sharing it with the community what we're doing. So we also have an account in GitHub that is NI System Engineer repository. And in here, for example, you can see the CEF. One of the nice things in here is we have also issue tracking. So if you're using these libraries and you have bugs with them, you can report them here as issues, and we normally will take care of them. I'm working on some of them, and all of these are documentations, but all the bugs have already been fixed. So with this, we're trying to have a better feedback with our Alliance members, and in general with everyone that is using our tools. So if you're using one of our tools, it can be more useful. If we cannot fix it, you can also go here, fix it, and submit it to us. So it's also something that we're trying to do to increase our interaction with the community and to make our tools easier to use and available to everyone. So as I said, you can go to GitHub and we have ni.com/reference designs. Here is all our tools, all the information that you're going to need. Okay. Any questions? Yes.
Is it easy to change the way to save the configuration? Like if I want to save in a database, it is easy to...
Yes. So, in general, when you're creating your system, when you create your template, you're going to get something like this. Now, the nice thing is when we're saving, what we have here is the save, and what we have is a ethos for save and load. So you can just keep using the rest of the system, go change this specific DI, and then you will save to a database. In many cases, for example, in the tag-based configuration editor, we're saving it normally on the as a TMS as an XML-like file. But you can also come to tools and we can save it as a binary, so nobody can read it, or load a binary file. So basically you can make backups like that and load them back. And what we have in here is we created basically two methods, and it's just adding stuff to the tools menu and just modifying it. In general, everything is on the block diagram. You just have to be or overriding some of the methods or replacing the VI with a specific VI. So what you have to do is check if the file is stored in your local directory or if it's stored in the in our repository. So if it's part of it, VI lib, you just have to override it. If not, you just have to change it. And as this top level VI will be on your folder, you can modify it and change whatever you want. So if instead of saying configuration, that was configuration editor, you can change in here to whatever you want to call your product. You can add your logo, you can change whatever you want. This is a project. So even if you update to new versions of CF, the top level VI won't be modified. Just we will update the methods and all the private properties of our system. Yep.
Is this implementation example included in the framework?
The tacos framework, no, basically it's another library, so you can download it, and it has all the information. It's a separate package. The two ones that are already there is basically the advanced one and the basic. That is the channels implementation.
So this this implementation of it is a separate download?
Yes. So the thing is, this one is a different framework. It's a tacos data framework, and this one is more for a single point acquisition. For example, if you want to get points from Modbus, you want information from Profibus, you want information from ScanEngine, and you basically want all to go to a PID. So we have a framework that allows you to do that kind of systems a lot faster. And as part of, we're not going to tell you reuse our libraries if we don't reuse them. So basically we use the CF to create the user interface for that system. But it's all you can download it on ni.com/reference designs. You can go data framework and you can download it from there.
And commercially, you're having a hands-on at 10:45
Yes.
on that one.
Yeah, the hands-on is on how to build the modules. So it's pretty good introduction if you have not worked with it. And also after that one, we have another conference that is Daniel is teaching of how to we basically compare a little bit between tacos data framework with the machine control reference architectures. Daniel, do you know what room is that one? Okay. Yep.
How many elements do you have in the tree control? I remember long ago using tree control, and you started getting to hundreds of thousands of elements and everything. Really that much.
So right now I have not find that many problems, and it goes a lot also on how you're managing your tree control. The thing is, for example, let's say here on channels on tacos module, I could have, or the channels that you're adding here on a table, so my tree control only has one element, or each element could be a tree control in here. I mean, you can expand it or make it smaller, and it will update.
How many have you done before in the tree?
On the tree, right now, the largest one, I think, was 150, and it was one that I had basically each channel on the tree control. The limits in here would depend on your machine. Also, machines can handle a lot more knobs, and it's more of a tree control limit. Okay. The comparison between tacos framework and machine control reference is 16 bit. Okay.
But do you disable the front panel when you update the tree? Because like that's what I find like what he's saying. Like if you have like over 100 elements, if you don't disable the front panel updates when you update the tree, it just
Yes.
So you are doing like something like that when
we refresh the tree, we basically disable the different panel updates, then you update all the tree, then enable the file.
okay, so you're
Yes.
When you save it, it'll do this. It'll shut down the UI so that you can interact with it, things like that.
So I'm curious how once you have the information out, how do you use it in the application? You just, I see it like that repo reference there. You just always read from the repo whatever you needed, or
yes.
populate your classes?
Well, it depends. I mean, in some cases, that's what we have been doing. So in the tacos framework, basically, we call the same repository that has all our information, and we call the configuration classes. In other cases, what I have done, more than what I have done is, they already built the embedded system, they already had a configuration file, and I just needed to create that configuration file. So basically, the thing that I generated from the CF was an exact copy of the configuration file they needed, and they already had all their system working. So it depends on the approach. If you're designing it from the beginning, it's really easy, and it has been really easy for us, reuse the repository, because you can read and write from file and into LabVIEW objects in a really efficient way. But it's not limited to be done that way. Yep.
I have a next question. When you choose a node in the tree, it is loading a page on the right side.
Yes.
And how the information are loaded? They are in the memory, or they can be loaded in...
Yes, so when you do certain things like save, load, or create nodes, the information is passed from the repository into the tree view. And now, basically, it's stored into the tree view. What we're using is DVRs, so we have objects, DVR to the objects, and that's how you access the information and modify it.
Okay. If you have a big project, it is hard to have this kind of configurator, because...
Not really. So the thing is, every node is pretty self-contained. So I think I'm running out of time, so I will just answer this one. So, for example, here in channel.
So it sounds like what you're asking is you want to have a sort of virtualized memory, right? You want to have a database, and then you only pull out the data for that particular node when you click on it. So that's certainly possible too. Again, that's the idea of abstracting away things in the configuration class, is you can make it so the configuration class just has a reference to your database, pulls out the information and displays it on the front panel when you click on that node. And as long as you use that configuration API, you can go through and you can grab the DVR for whatever you need, grab the configuration out of that and be able to manipulate it, because all you're doing is putting a reference to that same database, and you're accessing it through a good API that you developed for that particular type of class. So it's certainly possible to do that.
This is a simple example of the UI. So if you notice, basically I'm getting the DVR to the object. I'm just getting it out. We have a method to update the value and then closing it. So it's basically self-contained. Well, I think people are starting to get out of their rooms. Thanks for your time. Thanks for coming. And some of the sessions we're having after these, well, there's also, remember, the Launch of Keynotes Awards at 12:25, LabVIEW's Network Pavilion. We have all the demos and everything upstairs. And also, there's an Apple Watch giveaway.